All right. So, like I said, we have 3 Quizlets to go over. This first one, what is this one? This one is just the basic information. So this should be more of a review Quizlet. The second one will be the information on the quiz next week or this week. And then the third one will be what she discussed in lecture, although there wasn't really too much new information she covered in lecture. It was kind of just a review over Chem 1 periodic table stuff, but we'll go over a little bit of it. But we'll get started on this quick little Quizlet here. So an alkane, what was the, I think, yeah. So for these, I have the definition of it, but also the amount or like the equation to get the amount of hydrogen from the amount of carbon. So what do you think alkane is?
Isn't that the one with only the single carbon bonds?
Yeah, it's only got the single bonds. And then do you remember how many hydrogens you get from the carbons?
Uh, two.
The equation is carbon atoms times 2, and then you add 2 to get the hydrogen atoms. So for every carbon atom, or you count the amount of carbon atoms you have, multiply it by 2, and then add 2, and that's the amount of hydrogen atoms you have. I think there's 1 or 2 questions that kind of pertain to the equations. It's really not that important of a detail. It's kind of just to double check your work when you're drawing the structures, to know how many carbon atoms and hydrogen atoms you're supposed to have. Next, we have alkenes.
That one's with the double carbon bonds.
Yeah, it has at least one, and I don't think she actually taught you the equation, so I'll just teach you them here. But yeah, it has at least one double bond, but it does not have a triple bond. And then for this, all you do is you multiply the amount of carbon atoms by 2, and that's how many hydrogen atoms you have. You won't add 2 at the end, so it's just carbon atoms times 2. And that's because the double bond will take a bond away from 2 carbons, and that gets rid of the plus 2. And then you have your alkynes.
One or more triple bonds.
Yep. Hydrocarbon containing at least one. Oh, that's supposed to say triple. My bad. But yeah, a hydrocarbon containing at least one triple bond. And for this one, you have the amount of carbon atoms times 2, and then you subtract 2 because the carbon atom's taking 4 bonds away total. So you would have 4 less. So instead of plus 2 with the alkyne or alkane, you would subtract 2 in order for an alkyne. And then the aromatic hydrocarbons.
That's the it's essentially the same hydrocarbon but arranged differently.
Yeah, it's in this one. It's the benzene ring.
Mm-hmm.
So hydrocarbons that contain a ring structure similar to benzene. This is the quick format for drawing a benzene. You just draw a hexagon, and then you put double bonds on non-touching sides. So you can't have like a double bond here, here, and here. It has to be here, then here, and then here. Or you could have one here, here, and here. But that's like the quick way to draw benzene. You'll have to draw a lot of those in OChem if any of y'all are taking that. But Chem 2, it's kind of hidden in the background. You don't really need to know too much about it, but it is always good to know. And then you have your optical isomers. She talked about that for just a second.
Isn't that the mirrored image ones? Yep.
So it's any 2 molecular isomers that are mirror images of each other. There's a lot more in detail that I remember she went over, but in the lecture, she didn't really talk about them that much. So maybe y'all don't have to know as much about them as we did. But that's all that she said, basically, is that it's just 2 molecular isomers that are mirror image of each other. So that's just what you need to know. And then there is 2 words. You can either use optical isomers or enantiomers. And they both mean the same thing. And then we have cis isomers. Oh, I didn't mean to do that. But what is a cis isomer?
It's arranged I'm not sure. Is it just arranged differently?
So there's two types of, it's cis and trans. And so the isomer means two things with the same formula, but they're arranged differently. But the cis and trans part is kind of what we're focusing on here. So cis means that you're going to have the hydrogens, or you're going to have the same groups on the close side. So you're going to have, these two X's on the same side, on both on top of the carbons, or you're going to have both hydrogens below, or vice versa. But it's the hydrogen atoms and the double bond are on the same side. So you'll be shown a picture very similar to this, and she'll just ask if it's a cis or trans isomer. And then, so we'll go ahead and go to the trans isomer. And then the trans isomer is going to be when they're on different sides. So you're going to have the hydrogen up here and the hydrogen down here. And then the X, which X just represents anything. Like it could be another carbon, it could be any element really, but they're going to be on different sides. And so she'll show a picture really similar to this, and she'll say, is this a cis or trans isomer? And you just look and see if they're on the same side or different sides, and that's your answer. The best way to remember it is trans. This is a further distance than this, and so since trans is further, it's the longer word. That's the best way to remember it. And cis is closer, so it's the shorter word. Or you could do cis starts with a C and closer starts with a C. But either way, cis is the close one and trans is going to be on the opposite sides. And that's all we had for the first Quizlet. So we'll go back. Common functional group. So this is going to be what's on the quiz this week. It's the really important one for the quiz. And then we need to flip it and then shuffle. And this, oh no, we actually need it the other way. Okay. This is going to be pretty confusing to say the least, and you might not know them just from looking at this, but we'll go over each one so you can get more understanding. This is going to be the biggest detail we're covering today. So we're going to start with this one. We have a carbon bonded to a nitrogen. And there's only two of the, I think there was 10 total that she showed us, but there's only two that contain a nitrogen. Do you remember which ones those are?
Isn't that the amide and amine?
Yeah, amine and amide. And so do you know which one this would be?
Amine?
This would be an amine, yes. And so the way, I won't really, well, I'll just go ahead and tell. So an amide has a double bonded to oxygen in it, and then an amine doesn't. So that's the way to tell between amine and amide. But the way to tell if it's one of those two is just by the nitrogen. So if you have a nitrogen, you're going to be looking for either an amine or amide, and then you're going to look to see if it has a double bond to oxygen. If it does, then it's an amide. If it doesn't, then it's an amine. And this one doesn't, so it is an amine. All right. This should be the other one already. I think this would, what do you think this would be? It's set up a little differently, but that could help you overall because she'll give you the questions in multiple formats. So
would it be amide?
It would. And so, yeah, so you have, this represents a carbon, remember, because it's a bend in the angle. So this is carbon.
Okay.
And then it goes to the nitrogen. So that's carbon bonded to the nitrogen. So you know it's either an amine or amide. And then you see that double bonded to an oxygen. So you know it's an amide. All right. What do we have here? This is getting into some of the harder stuff. By the way, the R just represents another carbon. I don't know why they use R's instead of just saying C. But just think of this as carbon, carbon, hydrogen, oxygen.
Okay, I thought R. Yeah, I was confused as to why they put R. I thought R was like just like a replacement molecule that they just.
That's pretty much what it is, but it's almost always going to be carbon. So it's just helpful to think of it as carbon. Because if this wasn't a carbon, then it would be a weird molecule that we don't work with in Chem 2. So when you're looking at it in Chem 2 circumstances, it's almost always going to be a carbon. But yeah, they probably put the R because in other circumstances it wouldn't be a carbon. But this is going to be an aldehyde. And I think the way you know that is that it's a terminal carbon bonded to an oxygen. So this is a terminal carbon because it can't be bonded to anything else. It's going you can look at that as a carbon. So it's going carbon that way, and it's bonded to a hydrogen here and a double bond to oxygen here. So a terminal carbon double bonded to an oxygen, that's going to be your aldehyde. And most of the problems that she'll present you on the quiz, they aren't going to look exactly like this because she's going to give you an actual molecule. So let's go back. This is an aldehyde. Let's look up an example of an aldehyde real quick. And find a real one. There we go. So this is what she's going to show. She's going to put a real molecule like this. See how it's a carbon here. And you'll have to know that this represents that it's a aldehyde because it's a terminal carbon double bonded to an oxygen. It won't be as cut and dry as just this piece. It's going to be a full molecule. And then you have to look at the important parts of it to determine what it is. But terminal carbon. Oh,
sorry.
go ahead.
Would she highlight what the important part is, or like no?
I think if I remember correctly, last year she bolded it, but I would be prepared for either way.
Yeah. Okay.
The most important thing would be anything that has a double bond to an oxygen. That's going to narrow your list down. If it has a nitrogen, it's going to be either an amine or amide. There's a few other things that we'll look at further, but if it's double bonded to an oxygen, that's going to narrow down your list. And then the nitrogen so far. So what do we have here? We have a carbon, R prime, that should be another carbon. And then double bonded to an oxygen. So this is a central carbon. It's not a terminal carbon, it's a central carbon double bonded to an oxygen. Any ideas?
An alkene?
No, that would be a carbon double bonded to another carbon. But good guess. I think this, if I'm right, it's a ketone. Yes. So a ketone is going to be a central carbon. So just a non-terminal carbon double bonded to oxygen. So we'll look up an example. Actually, here's one right here. Here's a ketone right here. So it's a central carbon, a carbon in between other carbons, double bonded to an oxygen instead of hydrogens. And so I think this is kind of what the quiz will look like. If she highlights them, it'll be just a whole bunch of stuff like this. And you just have to say it's an aldehyde, it's a ketone, stuff like that.
Yeah, it's something like she said it'll be multiple choice and we just select which one it is.
Oh, so I remember for a fact she didn't do multiple choice for us last year.
Oh, man.
Yeah, it was really difficult.
Perfect.
Hopefully she gives you a multiple choice. That would help you all out a lot.
Yeah.
All right, so we'll keep going. All right, what do we have here? So here we have, it's a terminal carbon, but it's not bonded to an H. It's not bonded to hydrogen. It's bonded to an oxygen, then bonded to a hydrogen, and then it's double bonded to another oxygen. So we know it's not an aldehyde because an aldehyde wouldn't have this oxygen here. It would just be a hydrogen, and that would be it. So
would it be an alcohol?
Alcohol? No, this is the carboxylic acid. But that is a very easy mix-up to make. Let me look up the difference.
Look at her. She's getting titty.
Alcohol and carboxylic acid. There we go. Okay. Looking for one that has both. Okay, I think this, that's not really what I wanted. Okay, yeah, that'll work. Okay, so an alcohol, it's only going to be bonded to an oxygen. It's not going to have the double bond, but a carboxylic acid is going to have the double bond to an oxygen and the single bond to an oxygen.
Okay.
So, yeah, alcohol and carboxylic acid, very similar, but that's where I said the double bond to oxygen is going to narrow down some of your groups.
Okay.
So this is going to be a carboxylic acid because it has the double bond and a single bond to oxygen. Then we'll move on to this. So we have central atom double bonded to an oxygen, bonded to an oxygen, which is then bonded to a carbon. Okay, yeah. This should be an ester. Okay, I always got ester and ether mixed up. But an ester is going to be double bonded to an oxygen, also so very similar to a carboxylic acid, but then the oxygen is also bonded to a carbon. So we'll look up a picture of another ester. Ester functional group. Yeah, here. So it's a carbon double bonded to an oxygen, single bonded to an oxygen, and then bonded to another carbon. So basically think of a sandwiched carbon, I guess is the best way to say it, which also has the carboxylic acid connections of a double bond and single bond to oxygen. Does that make sense?
Mm-hmm.
Okay. All right, this one we just talked about. Is this a cis or a trans isomer?
A cis.
Yes, that is a cis because the H's and the X's are both on the same side. All right, and then this will be
Trans.
trans, yep. And what is this?
Alkene or alkyne.
Yeah, this is the alkyne because it's got that triple bond. And then we have
Alcohol.
alcohol, yeah, because it doesn't have that double bond to oxygen on top. It's just got the one oxygen and then hydrogen. And I don't know if it helps you all, but the way I remembered that was just I just something about the OH and then the OH and alcohol. It just helped me remember that alcohol has OH in it and the OH are right next to each other. That helped me remember. It's kind of a weird thing to remember, but that's always helped me. So yeah,
That's kind of how I memorized it,
Yeah.
since there's OH and alcohol, and it
Yeah,
just kind of
just kind of
clicked.
goes together. And what else we have? Okay,
Alkane.
it's a special type of alkane. Do you remember what the specific name was?
Haloalkane.
Yeah, haloalkane. And this is going to be really simple. She almost always has one of these on her quiz just because it's so easy to get. But yeah, it's just a carbon bonded to a halogen. And a halogen is any of those second to right, second to furthest right on the periodic table. Let me look up an example. Haloalkane. That's not what I want. Here we go. Yeah, so it's just going to be something like this. It's going to be pretty obvious because it's the only one that has something that isn't in anything else. It's going to have a bromine. Let me look up periodic tables so I can see which ones it could be. It is going to be any of these: the fluorine, the chlorine, bromine, or iodine. Iodine. It won't have whatever that is. Acetylene. I don't know. It won't have AT. It'll be one of these four. But like I said, it's very easy to recognize because it's just so obvious that it sticks out because none of these are in any of the other groups. And then sometimes she'll just straight up put the X, and that also isn't in anything else. So it's pretty easy to tell when it's a haloalkane. One thing to make sure is to make sure it's haloalkane and don't say it's a haloalkene or alkyne because that will be counted wrong. And that's all those. So we'll come back to this after we go over the last Quizlet. The last one really isn't that much. It's very simple, but we'll come back and go over those again since that's going to be on your quiz today. Y'all could learn it real quick and then go take the quiz today if y'all wanted.
Mhm.
All right, we'll full screen this and flip them around and shuffle. All right. What is the most common metal in the Earth's crust?
Common metal. Oxygen. We just wrote this down today. Silicone?
No, silicone's a non-metal.
Oh,
So then it would be
aluminum.
aluminum, yeah, with 7%. I'm pretty sure she has one question on the exam that has something like that. It's just picking and choosing information to remember. But I do remember that question being on the exam. So if you can find a spot stored in your memory, that would be good. But the most common metal in the Earth's crust is aluminum. Okay, what are the inner transition metals?
Isn't that the F block?
Yeah, the F block on the bottom of the periodic table right here. And that's all you really need to know about it at all. It's just that it's called the inner transition metals. The metals, which part of the periodic table would that be?
Isn't that the D group?
B. Oh, wait. Oh, sorry. This is not asking about that. This is asking about the characteristics of metals. I should have put that on the slide. So just give me like 3 characteristics of metals.
Oh, ductile, form cations, and conductors.
Yeah. So it's going to form cations. They're shiny. They're malleable and ductile, which means they can be malleable means they're beaten into shape, and then ductile means they can be turned into wires. But you just need to know the general term. You don't really need to know what they mean. They're conductors of heat and electricity, and they form basic oxides. So hydrogen or sodium hydroxide. Yeah. That's a basic oxide. All right. And then what is the most common element in Earth's crust?
Oxygen.
It's going to be oxygen with 49.2%. I don't think the percents really matter. I just threw them in there. The representative elements. You remember what? I think that's asking about the periodic table.
Not really. There was just too much for me to write down, so I couldn't get a.
Yeah, I got it. That's going to be groups 1, 2, and then 13 through 18. Those are considered the representative elements. Those are just the elements that you're going to be using the most when you're talking about chemical reactions and stuff, because you're not really going to use any of these as much because they're a lot more confusing with the way they form cations. You're mainly going to be dealing with groups 1, 2, and then 13 through 18. So just
Okay.
the raised part of the periodic table.
Okay, that's I guess that's why she said the S group and the P group.
Yeah, this is considered S, this is P, and then this is D and F. Yeah. Then the alkali metals.
Group 1.
Yeah, that's going to be group 1, and it consists of lithium, sodium, potassium, rubidium, cesium, francium. And all you really need to know is that they're very reactive. Those are the most reactive metals. And that's the furthest, this red column right here. That's the alkali metals. And then we have the alkaline earth metals. Oop, didn't mean to show that, but that's going to be your elements in group 2. They're harder than the alkali metals, which means they're less malleable, I guess is the best way to say that, and they're less reactive. That's the only 2 things you really need to know. But they're going to be in group 2, right next to the alkali metals. I think the only thing she really asks about them, I don't even remember a question about these. She just kind of asked which group is the alkali metals, which group is the alkaline earth metals, and then the halogens and the what is the last group called? Shoot, I can't remember. What is group 14?
Noble gases.
Noble gases. There we go. Sorry, couldn't remember that. Yeah. So those are the only four she really asks about: is alkali, alkaline earth metals, and then halogens and noble gases. And she'll just ask which group those are. And this is the characteristics of non-metals. Can you give me three of them?
Brittle insulators and acidic oxides.
Yep. And then the other ones would be that they form ions and they do not shine. So transition metals, that's the last question on here. It's just which part of the periodic table is the transition metals?
DNF.
Yeah, that DNF block right there and there. Nice. And then sometimes this row right here is considered transition metals. Sometimes it isn't. It's really iffy. Even Dr. Schultz goes back and forth on it. So take with that what you will, I guess. But mainly these for sure. And then also keep in mind that bottom or that last row is sometimes referred to as transition metals. And then now we'll really quickly go back over the functional groups, and that'll be the end of the session. We have 7.5 minutes left. So let's flip them. All right, we'll shuffle real quick. What is this?
Carboxylic. Sorry, I can't pronounce it.
Carboxylic acid.
Yeah.
Yeah, carboxylic acid because it's got that double bond and then the single bond to oxygen on a terminal carbon. All right, what would this be?
Trans.
Trans alkene, yes. What we got here?
Amide.
Amide, yeah, because it's got that double bond to oxygen, and then the nitrogen tells you it's either amine or amide, and that tells you it's an amide. All right, what we got here?
Cis alkene.
Yep.
Alcohol.
Yes, sir.
Haloalkane.
Yep.
Ketone.
Ester. So if you remember, the ketone is going to be carbon, carbon, carbon with the double bond to oxygen, but an ester is going to have carbon, carbon, oxygen, and then the double bond to oxygen.
Okay.
Yeah, ketone and ester are pretty easy to mess up. A lot of them are really similar, just have one or two small differences that you got to remember, and it just takes going over it multiple times. All right.
Ketone.
Yeah. Because think of it as carbon, 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 and then the oxygen.
Amine.
Yeah.
Alkaline.
Alkyne, yeah. And the last one.
Carbon, carbon, hydrogen. Ether.
Aldehyde.
Aldehyde.
Because it's the terminal. That one's going to be really hard to remember, I'll be honest. But a terminal carbon that's just double bonded to an oxygen. It's it's hard to remember because it's the simplest one.
Right. Yeah, I just kind of threw ether out there because that was the first one that popped in my head.
You want to go over them one more time, or you think you got it?
I think I got it. I printed out the PDF she had on the different groups, so I can use that as a study guide.
All right. Anyone else need to go over anything else before the quiz, or you think you got it?
I'm good.
Good.
I just gotta study some more.
Mm-hmm. All right, then. Well, I guess that will be it That
You
was
need
pretty
our
good.
UID numbers.
Yeah, if y'all could throw those in the chat real quick. And that'll be it for the session.
All righty. Thank you so much.
Yeah, good luck on y'all's quiz.
Yeah, thanks, man.
Have a good night.
Thank you.
Yeah, you too.
Thank you.